Right now, one moon in the solar system is falling. You can't see it. You can't measure it without years of patience. But every orbit, every century, every billion years, it gets closer to the planet that holds it. And here is the part nobody talks about. Out of more than 300 moons we have cataloged, this is the only large one that orbits in the wrong direction. Its name is Triton. It was stolen from the outer dark. It breathes nitrogen at -235 degrees Celsius. And one day, the planet that captured it will tear it open and wear the pieces as rings. This is the slow funeral of a stolen moon. I want to walk you through it. From the kidnapping 4 billion years ago to the burial that hasn't happened yet. Take everything that orbits the sun, every planet, every dwarf planet, every comet that came back when Newton was alive. They all move the same way, counterclockwise if you look down from above the North Pole. Same direction, same disk, same rotation that the gas cloud had before it collapsed into a star. Now look at moons, hundreds of them. Almost every one follows the spin of its host. Earth's moon, same direction Earth turns. Europa around Jupiter, Titan around Saturn, each one a small echo of the planet's own birth. Triton breaks the rule. It orbits Neptune backwards, against the spin, against the disk, against everything we expect a moon to do. And the angle is wrong too. 23 degrees off Neptune's equator. It doesn't ride the planet's spin axis, it rides its own. This sounds like a small detail. It isn't. In planetary science, the direction a moon orbits tells you where it was born. Forward orbit means born from the same dust that built the planet. Backward orbit means born somewhere else, brought here, or trapped. Every other large moon in the solar system has the first story. Triton has the second. And the second story is much more violent than the first. Triton did not start as a moon. It started as a free body. A small icy world drifting in the Kuiper Belt, the vast ring of frozen objects beyond Neptune's orbit. The same belt where Pluto lives today, where Eris lives, where countless dwarf planets we haven't named yet still spin around the sun on their own terms. Triton was one of them. Then something went wrong. Around 4 billion years ago, when the solar system was still young, when planets were still settling their orbits, Triton crossed paths with Neptune. We don't know exactly how. The most accepted model says Triton was part of a binary pair, two icy bodies dancing around each other. Neptune's gravity grabbed one, threw the other away. The one it kept, Triton. The kidnapping was not gentle. Neptune already had moons, small, regular, prograde moons, the ones that formed in its original disk. When Triton arrived, ripped from his old home, his orbit was wild, long and eccentric, cutting across the inner system of Neptune like a wrecking ball on a chain, and it wrecked. The original moons of Neptune, most of them, were dragged into crossing orbits and collided with each other inside 100,000 years. Shattered, smeared into rubble. Some of that rubble eventually reformed into the small, irregular moons Neptune has today. But the system Neptune had before Triton, that system is gone, erased by the new arrival. Triton settled into orbit on a ruin he made. And here is the part that gets to me. We always picture moons as quiet companions, faithful, patient. But Triton arrived like an invader. He didn't join the system, he replaced it. After the chaos, Triton's orbit eventually circularized. Tidal forces drained the eccentricity. The ruins of the inner moons absorbed the energy. By 1 billion years after the capture, the system looked stable. It wasn't. Because Triton orbits the wrong way, every tidal pull from Neptune slows it down. Not speeds it up, slows. Each orbit, it loses a tiny sliver of energy. Each lost sliver drops it millimeters closer to the planet. Millimeters a year. That sounds like nothing. It is nothing on a human scale. But geology doesn't work on a human scale. Geology stacks millimeters for billions of years. And the cliff Triton is walking toward has a name. The Roche limit. The Roche limit is the line where the planet's gravity pulls on the near side of a moon harder than the moon's own gravity holds itself together. Cross that line and a moon doesn't survive. It pulls apart. Not all at once. First the crust, then the mantle, then the core. All stretched into a ring around the planet that killed it. For decades, the textbook number was 3.6 billion years. Calculated in 1989 from Voyager data by astronomers Chiba, Jankowski, and Nicholson. Standard answer in every astronomy course. Then, in 2025, a reanalysis ran the model again. Better tidal dissipation numbers for Neptune. Better physics for the interior of an icy moon. The new estimate, 28 billion years, 8 times longer than the old number. You might think this is good news for Triton. It is, and it isn't. 28 billion years is longer than the universe has existed so far. Longer than the sun will burn. Longer than anyone will care. But it is finite. It is a number with an end on it. The clock has only gotten slower. It hasn't stopped. And while Triton falls, something is happening on its surface that we have only ever seen in this one place. In August 1989, Voyager 2 flew past Neptune. 6 hours. That is all the encounter took. The probe had been launched in 1977, when most of the engineers watching the playback at JPL were not born yet. It crossed 12 years of empty space, took a single hard look at Neptune, and then dove south toward Triton. What it saw at Triton, nobody expected. The surface temperature was minus 235 degrees Celsius, the coldest body any spacecraft had ever visited. Cold enough that nitrogen freezes solid like rock. Cold enough that if you stood on it without a suit, the air around your mouth would freeze before it reached your lungs. And yet, Triton was alive. On a moon that cold, every model said, dead, frozen all the way through, geologically silent, no activity for billions of years. Triton should have looked like a slightly bigger Pluto, cratered, still, finished. Voyager saw plumes, 8 kilometers tall, dark columns of nitrogen gas blasting up from the south polar cap, blown sideways by the thin atmosphere into streaks that ran for 100 kilometers downwind. Geysers in a place where geysers should not exist. Active geology in a world that should be a corpse. And the surface itself. Ridges and dimples in a pattern nobody had seen on any other body in the solar system. They called it cantaloupe terrain, after the rind of the fruit. Nobody has explained it convincingly. Even now, 37 years later, it is the only example we have of whatever process makes it. Here is what gets to me about this. 6 hours. 6 hours is all human eyes have ever directly had at Triton. Everything we know, every plume, every ridge, every measurement, came out of one rushed flyby in '89. Nothing has been back. Nothing is scheduled to go back. Triton is a world we glimpsed for an afternoon and have been guessing about ever since. If you put Triton and Pluto side by side, you would have to look hard to tell them apart. Triton, 2,700 kilometers across. Pluto, 2,400. Triton is bigger, but not by much. Their densities are almost identical, around 2.06 grams per cubic centimeter. Their compositions match. Water-ice mantle, frozen nitrogen surface, rocky core. Both came from the same nursery, the Kuiper Belt, the ring of icy bodies beyond Neptune. They were born next to each other, maybe within the same family of objects, maybe within the same generation, and then their paths split. Pluto stayed out there, cold, lonely, in a wide elliptical orbit around the sun, free, no master. He gets to keep his shape, his moons, his thin atmosphere. In 5 billion years, when the sun swells into a red giant, Pluto might briefly warm enough to be habitable. He might have a few centuries of liquid water before everything ends. Triton got caught. Same body, same physics, different gravity vector at the wrong moment, 4 billion years ago. And now one of them rides out the death of the Sun as a free planet, and the other one is going to be torn apart by tides and turned into a decorative ring. I think about this sometimes. We talk about astronomy as if it is physics, laws, equations, predictions. But the difference between Triton and Pluto isn't in any law, it is in a millimeter. A few meters per second of velocity in the wrong direction 4 billion years ago. Same beginning, different ending. No reason except chance. Eventually, in 3.5 billion years, or 28, depending on which model you trust, Triton crosses the line. Then the dying starts. First, the crust. The side of Triton closest to Neptune feels stronger gravity than the far side. The stretching becomes too much for the ice to hold. Cracks open. Whole continents of nitrogen ice flake off and start their own orbits. Then the moon loses its shape, becomes a long, deformed shard. Then a string of chunks. Then a stream of pieces. The pieces drift along the path Triton was already walking. They flatten out. They collide with each other and grind themselves smaller. Within a few million years, astronomically fast, Triton is a ring around Neptune. Neptune today has almost no rings. Thin, faint. You can barely see them in the best Hubble images. The same Neptune, in billions of years, will wear a system that rivals Saturn's. Bright, vast, the corpse of his oldest companion turned into a halo, and that is the part I keep coming back to. Saturn's rings, the most beautiful object in the solar system. They are made of dust from dead moons. Other systems have rings too, made the same way. Beauty in orbital mechanics is mostly just funerals that haven't finished. If this is the kind of story that catches you, slow, certain, made of physics that doesn't care about us, there is a whole channel of it under this video. Subscribe and you won't miss the next one. Tell me in the comments what object you want to walk through next. But before you go, there is one more question I owe you. Who is going to be there to see this? 3.5 billion years from now, or 28, pick a number. By the first one, the sun has started swelling. Earth's oceans have boiled away. The crust is hot enough to melt rock. Anything we built, gone. Anything we wrote, gone. Anything that knew our names, gone. By the second one, the sun is a white dwarf, a cooling cinder. The solar system is dark, except for whatever heat remains in the planets themselves. Neptune is still there, cold, lonely, with no sun to reflect. And around him, finally, a ring system, bright in the starlight that is left. Nobody on Earth will see it. No descendant of anything that lived on Earth will see it. Whatever life is around to watch the funeral, if any, will be from somewhere else, with eyes that evolved under a different star. And maybe nobody at all. Maybe the rings of Triton will form in complete silence, with no witness, in a solar system whose last conscious creature died billions of years before the show began. This is the part that hits me, every time I sit with it. Triton is falling right now. He is falling tonight while you watch this. He has been falling since before life on Earth was anything more than chemistry. And he will keep falling, with absolute mathematical certainty, long after every story you and I are part of has ended. The wrong way moon, stolen from the outer dark, falling in silence toward a planet that captured him by accident, in a universe that won't be paying attention. That is Triton.